Welcome to Math 2320, Section 4.4. In this section, we're going to look at a technique called the method of undetermined coefficients. It's a useful technique, but my driving function on the right-hand side has to be in a pretty special format. And if it is, we know what to do. Otherwise, we have to look for other techniques. So the first thing that we do in using the method of undetermined coefficients is I solve the homogeneous problem. So y double prime plus 6y prime plus 5y equals 0. So I form my quadratic equation, factor it. I get two distinct real roots. And so my homogeneous solution is C1 e to the minus x, C2 e to the minus 5x. My right-hand side is a constant. Alright, so since that is the case, I make a guess. I make a guess that my particular solution is some kind of a constant. Well, let's see if I did that. The first derivative is 0. Second derivative is also 0. Plug that into my non-homogeneous problem. So 0 plus 6 times 0 plus 5a, that was our guess, equals 10. And so that says that a is 2. So a particular solution is 2. So my general solution to my non-homogeneous problem is the combination of the homogeneous and the particular solution. So C1 e to the minus x plus C2 e to the minus 5x plus 2. So far so good. Alright, so looking at question 2. Second order constant coefficient differential equation. Right hand side has this forcing function. Alright, so I first form the homogeneous problem. M squared minus 12m plus 36 is 0. Factors into m minus 6, m minus 6. And so I get m is 6. So I get one real root, but it is repeated. So my homogeneous solution then is C1 e to the C6x, and because it's repeated, I get C2x e to the 6x. Alright, so based on the right hand side of 42x plus 4, my guess is a linear type of function for my particular solution. So first derivative of this is a. Differentiating it again, I get a 0. Alright, so now I simply plug all this back in. Second derivative is 0 minus 12a plus 36ax plus b. So I'm going to distribute this. And this should equal to our right hand side. Alright, so let's see. Let me grab this part that has an x in it. This part has no x in it. And now I'm just going to match them up. So 36a has to be 42. So that gives me a is 42 over 36, which would reduce to 7 over 6. This part, the 36b minus 12a, matches up with the constant 4. Plugging in what I know about a, alright, I get 36b minus 14 is 4, or 36b is 18, giving me that b is 1/2. So my particular solution has this format. I combine that with my homogeneous solution, giving me the general solution to the problem. All right, in question 3. All right, so I form the homogeneous equation, and m squared minus m is 0. All right, so I get m is 0 and 1. All right, so c1 e to the 0, e to the 0 is 1. So I get c1 plus c2 e to the x. Now, right hand side is -5. I would normally guess as a particular solution y p of x is a. But if I did this, this could conflict with that constant in these two situations. Remember, we want them to be linearly independent. So the way to patch this up when this presents a conflict is to start multiplying by powers of x. So my normal guess is a. I'm guessing ax. First derivative is a, second derivative is 0. So plug this in, I get 0 minus a is -5, and so I get a is 5. Therefore, my particular solution is 5x. And so, my general solution then is the homogeneous solution plus my particular solution. So again, if your guess in any way has a conflict with a piece of the homogeneous solution, you have to multiply by powers of x. All right, in question 4, we have second order constant coefficient. We have this driving function. So I form the homogeneous problem. M squared plus 1 is 0, so m is plus or minus I. Alright, so fairly straightforward. The homogeneous solution then is c1 cosine x plus c2 sine x. Now the right hand side is 7x sine x. Alright, so I've got this piece, which my guess would be ax plus b. And because I have a sine or cosine, I get the combination of them both. So I've got the ax plus b and the cx plus d because of the 7x. Now if I distributed this, I'd get ax cosine x. There's no problem. But this b times a cosine could present a problem here. And similarly, this d times a sine could present a conflict there. So my particular solution then would be x times my first guess. Alright, so here is my particular solution guess, and I need to determine A, B, C, and D. Now, this is a bit of a mess because I need first and second derivatives. These are product rules. Alright, so my first derivative, the derivative of the first piece, 2ax plus b. Then because of the product rule, this stays. The derivative of cosine is minus sine. I repeat that process for the sine pieces. And now to do the second derivative. Let's see, I've got 4 product rules, so I'm going to have 8 terms. Let's see, the derivative of the first part is 2a, and then the cosine x, and then all of that derivative of cosine is minus sine. So with caution, you have to proceed by doing the product rule for all of the pieces. Alright, now that we've got the first and second derivative, I need to start matching this up with y double prime plus y equals sine x, 7x sine x. Alright, so what I did is I put all the stuff in blue that involved cosine terms. And then I grouped together all the junk that had sine terms. And here's my right hand side. I did this simply as a way to keep track of all these symbols. This term, the ax squared plus bx, cancels this term because I've got a positive cosine and a negative cosine. And then with the sine terms, I've got this term cancels this piece. Alright, then I tried to gather together the stuff that I have with this cosine, a negative sine, and this sine. And it has to equal to 7x sine x. Alright, well, since the right hand side doesn't have any x cosine terms, that tells me that c is 0. Okay, well if c is 0, that's going to get rid of this term, so all of that's gone. What else? Well, let's see, there's no cosine terms at all on the right hand side, so 2d plus 2a has got to be 0. Alright, what about the b part here? Let's see. I've got a 4ax and a minus sine x. So that tells me that minus 4a must be 7. And I get a is minus 7/4. Well, we had over here 2a plus 2d is 0. So that says that d is minus a. Alright, and let's see this part, b is 0 because I don't have any constants times the sine. So putting together the pieces that I know, I end up with my particular solution, minus 7/4 x squared cosine x plus 7/4 x sine x. And when you combine that with the homogeneous solution, you get our general solution. Alright, and in our last problem we have something from physics and mechanics. Second order constant coefficient problem, driving function is sinusoidal on the right hand side. So I form my quadratic equation. I get m squared is minus omega squared, so m is plus or minus omega I. So my homogeneous solution, xh of t, c1 cosine omega t plus c2 sine omega t. Looking at the right hand side, my guess normally would be a cosine omega t plus b sine omega t. But clearly there's a conflict with the homogeneous solution. So I multiply here by powers of t because this is with respect to time. And so I get AT cosine omega t BT sine omega t. So this is not nearly as ugly as the last problem. Alright, so we form the first and second derivatives, product rule. Alright, so get that. Second derivative, I've got easy derivatives, I've got some product rules. And so now let's match it up. I've got x double prime plus omega squared x, my guess, and that has to equal to f0 sine omega t. Alright, so I'm going to try to keep together some things. Let's see. I'm looking at this first piece, this minus bt omega squared with a sign cancels the bt omega squared sign. I got a positive and a negative. Similarly with the cosine piece, I've got a piece there that cancels. And so what am I left with? Well, let's see. I've got a minus a omega, another minus a omega, so a minus 2a omega sine omega t. And for the cosine parts, I've got 2b omega cosine omega t. Now the right hand side doesn't have any cosine terms, therefore b is 0. So by matching this up, I get the relationship of minus 2a omega is f0. And I can solve for a. A is f0 divided by 2 omega. So that gives me my particular solution, which I combine with the homogeneous one. But this problem has more. We also have some initial conditions as well. So x at 0 is C1. Well, let's see. If I plug in 0 here, cosine of 0 is 1, so I get a C1. Well, both of these, this is a sine of 0, which is 0. I've got this term, when it's 0, it's missing, and so the only thing I get is C1 is 0. That means the C1 cosine is gone. And so now I'm looking at the first derivative. So here's my first derivative, and again at 0, it's supposed to be 0. Well, let's see. Cosine of 0 is 1. Cosine of 0 is 1, so I get that piece. Sine of 0 is 0, plus it has a t in it, so that's missing. And so I can solve this for C2. And C2 is going to be f0 over 2 omega squared. Giving my function, x of t is f0 over 2 omega squared sine omega t, and then a part involving t and a cosine. So the method of undetermined coefficients is useful. It's not too terrible. It can be long and tedious, as we've seen in some of these problems, but it is a good technique.